So here's our next example. Again, you could pause the video to write it down. I'm just going to read it through. A nice storm caused the 14-meter hydropole to lean over. The top of the pole is now 9 meters above the ground. Find the measure of the angle between the hydropole and the ground to the nearest degree. So what we have is, so I was going to draw the situation. We have kind of like our hydropole, and it's leaning over, and there's the ground. So that's what it looks like. So we're going to draw a triangle. It's going to be a right angle triangle because that's all we know how to deal with right now. The top of the pole is 9 meters above the ground. So that's the top of the pole, and it's 9 meters above the ground. So that's going to be 9 meters above the ground. The hydropole itself is 14 meters. So that's the hydropole. So this is going to be 14 meters. What we want to do is we want to find the measure of the angle between the hydropole and the ground. So this is the ground, that's the hydropole. This is going to be the angle we're looking for, and that's going to be angle X. So we could go and solve this thing now. So what we know, that's our angle, then this is the opposite, this is the hypotenuse, this is the adjacent. We're going to write a SOHCAHTOA on top. And, okay, once again we have opposite and hypotenuse, so it's going to be sine again. So it's going to be sine of x equals 9 over 14. The way we deal with that is x is the inverse sine of 9 over 14. I'll plug it into the calculator. The inverse sine of 9 divided by 14. And that's 40 degrees on the nose. Well, that's kind of neat. I should remember that one. So it's 40.0 degrees, which is 40 degrees on the nose. Now, of course, this is a word problem, so we have to say, therefore, the hydropole makes an angle of 40 degrees with the ground. Okay. Let's do example 3. So again, I would pause it if you're not ready for it. A tree and a smart mouse are 17 meters apart. A coconut is at the top of the tree. The angle of elevation from the mouse to the coconut is 57 degrees. How far away is the mouse from the coconut? So we're going to draw this thing. We have the tree. At the top of the tree we have the coconut. Here's the mouse. And the mouse is looking, we want to know how far away the mouse and the coconut are from each other. So, we're going to make a diagram. I kind of already drew it, but we'll do it again. Mouse, coconut. A tree and a smart mouse are 17 meters apart. So this is 17. The angle of elevation from the mouse to the coconut is 57. So angle of elevation is between the horizontal and the line of sight. So this is 57. How far away is the mouse from the coconut? Mouse, coconut, that's our X. By the way, I put a 90-degree angle there. It didn't actually explicitly say that, but in general, trees, buildings, people, they all make 90-degree angles. Cliffs, they make 90-degree angles with the ground, unless it says otherwise. For example, obviously Leaning Tower of Pisa would not be 90 degrees. because it leans. We're going to label our sides: hypotenuse, opposite, adjacent. Let's SOHCAHTOA this thing. So SOHCAHTOA. We want adjacent and hypotenuse. That's going to be this one over here. That's going to be cosine. Cosine of 57 degrees is 17 over x. We have an x on the bottom, so what we have to do is we have to multiply both sides by x. X cos 57 equals, chink chink, equals 17. We're going to divide both sides by cos 57. And x equals 17 over the cosine of 57. 17 divided by cos 57 is 31.2. So x is 31.2. Then we look, the units were meters. So how far away is the mouse from the coconut? Therefore, the mouse is 31.2 meters away from the coconut. Okay.